dealing with similar figures. Let's backtrack. A couple of chapters ago, we talked about congruent figures. Remember what determined that figures were congruent. All of their corresponding angles were congruent, and all of their corresponding sides were congruent. And what that ended up giving us was two figures of the exact same size and shape. What we're dealing with similar figures is that these figures will be the same shape, but not necessarily the same size. So all of their corresponding angles will be congruent, as you can see in the definition, and all of the corresponding sides will be proportional, which means that we can set up ratios using those corresponding sides. When we're talking about similar figures, they have more than two pairs of sides. They'll have at least three. So we use what we call an extended proportion to describe those sides. Once again, throwing it back to way back in chapter 4 when we talked about congruent figures, you may recall that the first kind of example that we dealt with was, here are two congruent figures, tell me what's congruent to what. And that's kind of where we're starting here. However, the angles are what's congruent, and then for the sides, we're setting up the extended proportion. So part A is easy. Remember, the polygons are always going to be named in order of their corresponding parts. So even without a diagram, remember, the beauty of it is, you know, the first letter corresponds to the first letter. So right away, for part A, for example, we could say that angle Q is congruent to what? Even though I don't have a diagram, I just know. Go ahead and say it. Angle D. Angle R is congruent. Angle E. And angle S is congruent to angle F. For part B, what they're asking us is an extended proportion for the corresponding side lengths. Here's what it would look like. You'd have QR is to DE as, what could I have next in this? Absolutely. RS is to EF as the other side of the triangle. SQ is to FD. Okay, so that's going to be one of the kinds of problems that you'll encounter in your homework tonight. Identify the congruent angles and write out the extended proportion. Make sure that you remember what they're asking you for. So far, pretty easy. The bulk of what you'll be doing, however, and they're on the screen. And I am seeing that I didn't emphasize adequately what the symbol is for similarity. Remember that the congruence symbol was an equal sign with a squiggly line. That symbol demonstrates that the size and shape are congruent. Here, since only the shapes are the same, I don't have that equal sign. It's just the squiggly. Okay? Make sure also that you are naming things in order of their corresponding parts. Okay, so your answer for the similarity statement doesn't have to be in the exact same order, but you want A in the same place as S, B in the same place as R, C in the same place as B, if you get what I'm saying. Okay, we good on this? So how do I use similar figures in order to find segment length? Notice where the X is. Any thoughts? Any hunches? Jesse? Okay, you actually don't, but I really do appreciate that you brought that up because that's one of the most common mistakes that happen. And hopefully it sticks in your mind that that's not what you do. You want to remember that you're setting up proportions. These sides are proportional. All right, so what you would do is set up the 16 over the 24, perhaps. And then what would be on the other side of the equal sign? 16 is to 24 as x over 20, yes. And then again, this is why you spent yesterday refreshing your memory on how to set up and solve proportions. So that this whole concept of cross-multiplying and solving would be elementary to you. So 24x equals 320. And I have 13.3 repeating. You got the same thing as me? You could also have 40 over 3. There wouldn't be a darn thing wrong with having that fraction answer. That's fine also. Questions there? And now, let's take this and apply it. In number 4, we have this picture, and we're enlarging it to fit on a blackboard. So let's first make sure that we know what we're being asked for. We're being asked what is the largest possible enlargement that will completely fit on this blackboard. Ideally, does it make sense that if the dimensions of the picture are proportional to the dimensions of the blackboard, that means that the picture and the blackboard are similar and it will fit perfectly enlarged. Does that make sense? Okay, so that would be ideal. Let's see if that's actually the case. So the picture is 5 by 7, and I want to check whether that picture is similar to the blackboard. But oh, the blackboard is in different dimensions, and even more funky, it's in feet and inches. So let's just convert that feet and inches into straight inches, because it's a lot easier to do that than to convert feet and inches into a decimal version of feet. So, how many inches are there? 12. So how many inches are there in 4 foot 2 inches? 48 plus 2. So I'd have 50 over 144. So is the picture similar to the blackboard? Yes or no? No, these two fractions don't reduce to the same thing. Okay? So what's going to end up happening, and you have to kind of use your imagination to realize how this would happen in the real world. I could either take the picture and enlarge it so that the length of the picture fits perfectly on the length of the blackboard, or I can enlarge the picture so that the height of the picture enlarges to perfectly the height of the blackboard. Understand, however, that in one of those instances, I'm going to have some empty space on the blackboard, whereas in the other instance, it's not even going to fit the blackboard. Does that make sense? Okay, so we have to figure out which one fits on the blackboard. So what we end up doing, get this out of the way. Oh. What we end up doing is setting up and solving two separate proportions. Okay, so I could take the 5/7 to the dimensions of the picture and enlarge the 5 to match the 50 and figure out what its corresponding width would be. Or I could take that 5/7 picture and enlarge the 7 to to match the 144. Actually, let me use a different variable. Do the two proportions make sense? All right, so let's figure them out. 5x equals 350, so x is 70. That means that the dimensions of this enlargement would be 50 inches by 70 inches. Does this fit on my blackboard? Yes or no? Yes. So once again, we could, if we didn't catch that, or if we had done the other calculation first, we could end up solving two separate proportions before we end up finding our answer. Just in the interest of being as thorough as possible, let's solve this proportion as well, just so that you see how the numbers work out. We have 7y equals 720, which means y is 102.9 approximately. Which, as we mentioned earlier, this enlargement, notice its dimensions. This enlargement would be 102.9 by 144. You see that it wouldn't fit. It's too big for our 50 by 144 blackboard. Okay, so this is our answer. This is the largest picture that can be enlarged onto that blackboard. We have from this screen what we need. Last example deals with scale drawings. And once again, this is something that you might have already dealt with before. Notice in this problem that we have the Space Needle is 605 feet tall. I'm trying to draw the Space Needle on a standard sheet of paper, 8.5 by 11, and I'm using the scale 1 inch by 50 feet. And I'm being asked if this is a reasonable scale. That's a yes or no question. Think about that last problem. Give me a reason. Okay, so if I did 50 feet, give me your math that you calculated. And you got? The answer again is no. Wonderful. And give me a moment and I'll activate the daily quiz on Socrative. Make sure that you're copying the assignment down.